Okay, today we're going to talk about properties of similar triangles, what proportional relationships are formed when parallel lines or segments intersect other lines or segments. Our learning goal is to use properties of similar triangles to find segment lengths, apply proportionality and triangle angle bisector theorems. First up, our first theorem is called the triangle proportionality theorem. Triangle proportionality theorem says if a line parallel to a side of a triangle intersects the other two sides, then it divides those sides proportionally. Yeah, you should write it down. If a line, you should write down the title of it and the theorem itself. If a line parallel to a side of a triangle intersects the other two sides, it divides those sides proportionally. It may help to draw the diagram, just a quick diagram real quick. Okay, if I have triangle ABC, and you'll see what this theorem says is that if EF intersects that triangle and is parallel to this bottom side down here, that means that side AB can be split as a proportion to side AC. Here's how. AE over EB is equal to AF over FC. Our triangle proportionality theorem, pretty simple. It's not going to involve anything that's too radical. Okay. This is a pretty simple theorem. Okay. In the end, guys, if you see a line that's parallel to one of the other sides of a triangle, okay, splits it proportionally. By now, when I say proportionally, you guys should have an idea of what we're talking about, right? Proportionally. Okay, you're going to hear it a lot today. All right, next theorem, very similar. If a line divides two sides of a triangle proportionally, then it's parallel to the third side. Okay? Yeah, I like the eyebrow back there. Mr. Ott, didn't I just write this down? What you wrote down before was that if a line is parallel to another side of a triangle, then it is proportional. What this says is if a side length is proportional amongst an intersecting line of a triangle, then the line is parallel. Okay. So we call this like, yeah, no. We call this the converse of the triangle proportionality theorem.
Basically, if two lines are parallel,
then they're what? When they're proportional. That's the big idea we need to talk about today, right? Okay. If your hypothesis is that these sides are proportional, I'll show you an example here. We'll go 2 for 1 for every 4 to 2, okay? Would those be proportional?
Yeah.
Would 2 over 1 equal 4 over 2?
Yeah.
So your conclusion would be that EF is parallel to BC.
So it's the complete opposite of what you just said.
It's not quite the complete opposite. It's just switching switching the words around. All right? Why do we have to learn it? You know, we learn our theorems so that you can apply them in crucial parts of this class.
But why do we
such as your EOC.
Does that mean the same thing?
Because in some problems, you're going to be asked to determine if the sides are proportional, given that the lines are parallel. In other problems, you're going to be asked to determine if the lines are parallel, given that the sides are proportional. It's one concept that you can apply 2 ways. No, you'll be fine. You only remember one concept, which is proportional sides, parallel lines. But, like the good 15, 16, 17-year-olds you are, you will find a way to complain about it. Okay? Anybody need this any longer? You just wrote it down.
So you're
Who's wrong?
26.
Who is
Not
better?
here.
26.
Who's wrong?
Alright,
Carl. It was down.
Well,
Okay,
okay,
Carl,
well,
let's
let's say
say
that
that
I'm
playing,
given that ST, let's just say this. Hey guys, given that ST is parallel to UV, it means that, look at this, STU over U to R is proportional T to V over V to R. Okay? Remember, I said you're going to have to understand one concept. You'll be asked to solve it multiple ways. For this to be true, right, if the lines are parallel, that means I'm going to have to set up a proportion. I want to set up my proportion such that x over 14 equals 4 over 10. What do I do from there? You cross multiply. And by golly, you're going to be cross multiplying for a while, okay? We're going to be doing it over and over and over again because we're dividing things proportionally. Everybody with me?
Yeah.
Good deal. Let's see if you're with me or not. Go ahead and find this length right here, P to N, okay? Give you a couple minutes to do this. Set up the problem. Let's try to go through this problem, okay? Right. First off, I'm looking for P to N, so I'm going to put an X right there. That's the side, or the portion of the side that I'm looking for. 3 over X equals 2 over 5. Nope. 3 over X equals 2 over 5. Okay? I cross multiply, I get 2x equals 15. Divide both sides by 2. X should be 7.5.
I took a guess and said 7.
7?
That was
Is 7 and 7.5 the same?
It's
It's so close. But unfortunately, Philip, let's say this was your house. And you were doing construction on it. And it should be 7.5 feet, your living room, and instead it's 7.
I would say that was close.
Yeah, most people would say that's fine. Some people would be like, no. And those people would say, nah. No, they're not.
That's like that
I would be guys like, I don't care, it's only half a foot. There's other people that wouldn't. So we have to accommodate for those other people.
I would just have to spread it.
You have to love it or list it and all that kind of stuff.
Right.
You get them like
7.5.
people
Alright.
in there that are like,
Next. Now, look. This is the example that some of you guys are fretting over. Verify that DE is parallel to BC. I'm trying to verify that these are parallel. How would they be parallel?
because
If
they
the-
just made it even.
Listen to me. If the side lengths are proportional, okay? So what am I going to do here? 8 over 12 would have to equal 10 over 15. In your warm-up today, when I said, hey guys, how can I check to see if this is true or not? I wasn't just yanking your chain, okay? I want to see, how can I check to see if that's true? Put in your calculator. Check the decimal forms. You can check the simplified fraction form, right? But it's easier to just hit that S to D button and see if it has the same decimal. 1/6, 0.6 repeating, 0.6 repeating, right? On both sides of
For a
it.
little while, they just said,
So I got 0.6
I said
equal to 0.6 repeating,
wow.
wow.
right? Then I've got proportional sides. They have the same ratio. What is my conclusion? Put it all together. What question was being asked? Verify that what? Are they parallel? That's all you gotta say. And Ms. Bridges, if you want to know why we had to write down the converse, it was because this is the converse. When I'm looking for the parallel sides, I use the converse, okay? If you write triangle proportionality theorem, I'm fine with that, all right? That's fine with me. Okay?
Said we write either of the two, don't worry.
For me, for the state of Georgia, probably not. Okay? Where you gonna see something like this? Approved. Approved would be a good one. Question. Question. Question.
Well, will you ever have to solve B to C?
Will you ever have to solve B to C? Yep. I'll show you how to do that later in the semester. Okay? Alright. A to C is 36. B to C is 27. Verify for me that DE is parallel AB. Now it just got real, right?
Oh, you would do,
Zero.
you would do
Hey,
36
hold on.
minus
Hey, homie. What I want you to do is I want you to write all that down.
It's proportional.
So we, I know mine, circle that, or.
The whole thing is 36. How far? Hey, check it out. A to C is 36 total. How many would A to D be? 16. 36 minus 20, correct? I read the problem.
Like, how'd you get 36?
Okay? B to C is how many total?
27.
What's B to E? So, well, thank you. So 12 over 15 would have to equal 16 over 20.
4 out of 5.
Does it? This is 4/5, and this is 4/5. Does that mean that DE is parallel to AB? Yes, that's what the question asks, okay? It's what the question asks. Any questions on that? On any of it? Y'all see what you do now? If you've got the entire side length and you just need a portion of it, subtract away whatever you've been given, okay? Everybody with me?
Yeah.
I think we're almost done. We might just have maybe 2 or 3 more. Alright, hey, go ahead and write this whole thing down. I'm not going to touch you on it too many times. 2 transversal proportionality. If 3 or more parallel lines intersect 2 transversals, then they divide the transversals proportionally. Okay? Understand what this means? This means that go down your parallel lines. So in this case, those lines are parallel. AC over CE is proportional to BD over DF. Okay? You're gonna have a tendency to go this way, and you don't want to do that. In this case, I would go vertically for my proportionality. Alright, let's see what this might look like. You're gonna get it excuse me.
It's legal until someone.
You would get it in a question that looks like this, okay? You can't even see. Suppose that an artist decided to make a tree, a larger sketch of the trees, because that's what artists do. In the figure, if AB is 4.5, BC is 2.6, CD is 4.1, KL is 4.9, find LM and MN to the nearest tenth of an inch.
What is KO? I can't see that.
Yeah, you can't see it. They're over here. So KL, LM, MN. Okay, I just want to make sure that we set this up correctly. Okay. Earlier, our parallel lines were doing what? They were going horizontally, right? In this figure right here, the parallel lines are going horizontally, correct?
Yeah.
What's happening here?
They're going vertical.
Yeah, they're going vertical, right? Okay? So when you set up your proportions here, you're not going to go top to bottom, you're going to go left to right. So 4.5 over 2.6 would equal 4.9 over x. And then you set up another proportion. 2.6 over 4.1 equals x over y. You have to go on from there, okay? I won't do the whole problem for you, but we'll get going with it.
Oh yeah, that's outside.
Okay, let's go ahead and write this down. Our triangle.
Hey, Rex.
Oh no, you okay? All right.
The butt? Yeah, like.
Triangle angle bisector theorem. An angle bisector of a triangle divides the opposite side into two segments whose lengths are proportional to the lengths of the other two sides. This means that BD over DC is proportional to AB over AC. Okay? BD over DC is proportional to AB over AC. Write all this down. This is called, again, the triangle angle bisector theorem. Angle bisector of a triangle divides the opposite sides into two segments whose lengths are proportional to the lengths of the other two sides of the triangle. We're on bigger, better. What might this look like? Hey, check it out. Okay, so remember when you're setting up this particular theorem, okay, you've got to pay attention to what sides are proportional. In this case, okay, watch me here. In this case, angle Q is getting bisected, okay? So the side lengths that are proportional are going to be over here. X minus 2 over X plus 5. See that?
Mm-hmm.
Okay? What people have the tendency to do is put X minus 2 over 32. X plus 5 over 40. You don't want to do that. Okay? X minus 2 over X plus 5 would equal 32 over 40.
No.
Okay? Alright? So you got, where's the starting point? The angle that's being bisected is the starting point. Okay? Go to the opposite side of that, and whichever side is opposite the angle being bisected, that's your first fraction. Alright? The other two sides are your second fraction. Looks like we're going to be using distributive property. We're going to solve that one, right?
Is that it?
That's it. Any questions today?
Do you have homework?
You have homework. You do.
Let's go.
You do have homework. But